Welcome back. Today we're going to go ahead and talk about solving inequalities. This is going to be our day number 2. Our content objective is students will be able to solve and graph 1 and 2-step inequalities. Language objective is students will be able to write inequalities from word phrases. Why am I learning this? Well, we can use some of these to figure out the maximum number of items you can store on your cell phone. So first, let's take a look at this table here. It says to answer the questions in the table below. So let's look. It says apply each operation to the inequality 4 less than 6. What is the result? And is the inequality true or false? So let's start with 4 is less than 6. For number 1, they want us to first add 4 to both sides. Okay, so let's do that. If we add 4 to both sides, we end up with 8 is less than 10. Is that true? Yes, it is. Okay, let's take a look at number 2. So first, starting with 4 less than 6, we're going to go ahead and add a negative 4 to both sides. Okay, so let's do that. Negative 4 plus 4 is 0, and 6 plus negative 4 is 2. Is 0 less than 2? The answer is yes, so it's going to be true. Number 3, subtract 10 from both sides. So here, if I take 4 and subtract 10, which is basically adding a negative 10, the same thing, I would go ahead and have negative 6 on this side, which is going to be less than a negative 4. Is that true? Also true. Number 4, multiply both sides by 4. Okay, so starting with 4 less than 6, let's multiply both sides by 4. We're going to get 16 is less than 24. Is 16 less than 24? Yes, so that is, again, true. Number 5, divide both sides by 2. So here we have 4 is less than 6. We're going to divide both sides by 2, leaving us with 2 is less than 3. Is that true? Yes. So again, that's true. Now let's take a look at number 6. Starting with 4 is less than 6. We're going to multiply both sides by negative 3. That's going to give us negative 12 is less than negative 18. That's actually false. That is not true. A negative 12 is not less than a negative 18. Number 7, divide both sides by negative 2. So here, 4 divided by negative 2 is negative 2, and that's going to be less than 6 divided by negative 2, which is negative 3. Is negative 2 less than negative 3? The answer is no, so that is also false. So looking at this table, did you notice anything? When did we end up with true statements and when did we end up with false statement? What is causing an inequality to become false? Well, the truth is you're going to find that anytime you multiply or divide by a negative number, you will flip, aka reverse, the inequality symbol. Okay, so this specifically works with only multiplying or dividing a negative number. Notice it did not work with adding a negative number or subtracting a negative number. So please remember that. Only when you multiply or divide by a negative number. So this is a question that I want you to constantly ask yourself as you're working out these inequalities. Because if the answer is yes, you did multiply or divide by a negative number, you're going to have to make sure you reverse the inequality. So let's look at a proof. Here we have 8 is greater than negative 3. That is true. Now, if we multiply both sides by negative 2, we end up with negative 16 is less than 6. That is not true. So what must we do? Well, didn't we mention from the previous slide, if we are multiplying or dividing by a negative number, we will have to switch the sign. So we're not going to be using the greater than symbol anymore. We're going to switch it to the less than symbol. So instead of negative 16 is greater than, we're now going to say negative 16 is less than 6. Okay, so everything stayed the same except for the sign switched from a greater than to a less than symbol. Now, is that true? Well, is negative 16 less than 6? Then yes, so there's now a true statement. Okay, so let's take a look at now what if we multiply both sides, divided both sides by a negative number. That's going to leave us with negative 4 is greater than 3. Sorry to break it to you, but negative 4 is not greater than 3. So this is not true. So what are we going to do? Well, we did divide by a negative number, and according to the rule, whenever we multiply or divide by a negative number, we must switch the signs. So I'm going to go ahead and switch this sign here to no longer greater than, but now less than. But we're going to keep the -4, and we're going to keep the 3. So now, is -4 less than 3? The answer is yes. So this would be our final statement. So again, we need to remember and recognize whenever we're multiplying or dividing a negative number, the signs will switch. Now, keep in mind, this is if you're doing this to both sides. It's not something that was already there. So for example, if it was 8 is greater than -6 and I just multiplied both sides by 2, okay, I'm not going to switch the signs because I multiplied both sides by 2. Don't think that, oh, well look, it's a -6 times a 2. There's a negative number, so I must switch the signs. No. You're only switching the sign if you're doing multiplying both sides by a negative number or dividing both sides by a negative number as well. Okay. So now let's go ahead and take a look at number 1. So we're going to solve this inequality like we did from our previous lesson. So since this is 5 times k, I'm going to do the inverse, which is to divide both sides by 5, leaving me with k. Let's take a second. Did I multiply or divide by a negative number? The answer is no. So guess what? I'm not going to switch this inequality sign. It's still going to stay less than, but now it's going to be a 6. So I'm just going to do a quick sketch of this graph. We're going to start with a 0, and then 6 is going to be on the right-hand side. I always like to first start with the open circle. Now, since it says less than 6, I'm going to go ahead and draw a line all the way to the left to indicate all the numbers less than 6. Now here, notice I'm not going to fill it in. Why? Because it doesn't say equal to. Now if it did, I would take that extra step and then fill it in. Okay, so now let's take a look at number 2. Well, number 2 is a -2 times x is greater than 16. So since this is multiplying by -2, I'm going to do the inverse, which is divide both sides by -2. So that's going to cancel out. And here, I'm going to take a second and I'm going to think. I'm going to be left with x. Now again, I'm going to ask myself, did I multiply or divide by a negative number to both sides? The answer is yes. I did. So because of that, I'm not going to keep it as a greater than symbol. I'm actually going to reverse it. So now it's going to be a less than symbol. So I did switch the signs. Why again? Because I divided both sides by a negative number. So now let's simplify 16 divided by -2. That's going to be -8. So this would be my final answer. So I'm going to go ahead and graph that. Starting with a simple number line, I'm going to first mark a 0. I'm going to now mark a -8. Starting with an open circle first, since x is less than -8, I'm going to go ahead and point to all the numbers that would be less than -8, which would be to the left. Since it doesn't say equal to, I'm not going to go ahead and fill it in. So that is it for number 2. Okay, for number 3 here, this means x divided by 7, which a lot of you would read it as x over 7. Notice I am trying to change that to dividing. Why? Because then I can understand if it's division, I'll know the inverse of dividing is to multiply. So in attempts to isolate x, I'm going to go ahead and multiply both sides by 7. I'm going to go ahead and put it over 1 so I can see they can cross cancel, and multiply both sides by 7. So here I'm going to be left with x. Now I have to think, did I multiply both sides by a positive or negative number? Sorry, let me rephrase that. Did I multiply or divide both sides by a negative number? The answer is no. I multiplied a 7 to both sides. It wasn't negative. So the sign's going to stay the same. So it's going to be greater than or equal to -56. Okay? So again, please do not be confused and think, oh, look, I'm multiplying 7 by a negative. I must be switching the signs. The answer is no. You need to make sure if you're if you're multiplying both sides by a negative, then you'll switch it. Or if you're dividing both sides by a negative, you would also then switch it. So just keep that in mind. So now that I have this, I'm going to go ahead and do a quick sketch of this graph. First starting with a 0, we're going to go ahead and mark a -56. Always starting with an open circle first. X is greater than So since it's greater than, I'm going to point all the way to the right because that's all the values greater than negative 56. But since it's also equal to, I'm going to go ahead and fill that circle in. So it means it includes negative 56 as well. Now it says here for numbers 4 through 7, it says for each of the following inequalities, explain if you would have to flip the sign when solving. So they're not really asking us to actually solve it. They're just asking us, are we going to have to flip the sign? Yes or no? Well, let's see. Since this is 2 times k, we're going to have to divide both sides by 2. Since I divided both sides by 2, is that a negative number? Nope. And for that reason, I'm not going to switch the signs. Okay, for number 5, this is negative 10 times k. So the inverse of multiplying by negative 10 would be to divide both sides by negative 10. And remember, you only switch the sign if you're multiplying both sides by negative or dividing both sides by negative. So in this case, since we are dividing both sides by a negative 10, the answer is yes, I'm going to have to switch my sign. For number 6, we have r over 3 is less than negative 6. And in order to solve r, not solve for r, but isolate r, we're going to have to do the inverse. So this is r divided by 3. So the inverse of dividing by 3 would be to multiply both sides by 3. So in this case, am I going to have to flip the sign? And the answer is no, because to both sides I multiplied a positive 3. It's not negative. And so for those reasons, I'm not going to change it. So don't, again, just think in your mind, oh, look, there's a negative 6, so it's probably going to change. The answer is, are you multiplying or dividing both sides by a negative? So keep that in mind. Okay, and last but not least, for number 7, we have t divided by a negative 8. Since the inverse of division is multiplication, I'm going to go ahead and multiply both sides by a negative 8. So here, am I going to have to flip the sign of the inequality? The answer is yes. Because you're multiplying both sides by a negative value, it will cause us to flip the inequality sign. Okay, so now that we've had some practice, let's go ahead and continue solving some more inequalities. Why don't you pause the video and try number 8 and 9 by yourself. Okay, so let's go ahead and go over the answers. For number 8, it says x over negative 5 is less than or equal to 10. Since it's x over, I can also read that as x divided by a negative 5. The inverse of division would be multiplication, so I'm going to do negative 5 over 1 just to kind of see if they can cross cancel. Keep in mind, I am doing this because I'm wanting to create a 1. That's basically applying the multiplicative inverse. Now, I went ahead and multiplied the left side by negative 5, so I have to multiply the right side by negative 5. So that's going to leave me with x. Now before I write the sign down, I'm going to ask myself the same question. By any chance, did I multiply or divide both sides by a negative number? The answer is yes, I multiplied both sides by a negative 5. So this sign's going to have to switch to greater than or equal to, not 10, sorry. Let's fix that. It's going to be a negative 50. So let's go ahead and graph that on a number line. First, starting with the number 0, I'm going to graph a negative 50. I'm always going to start with an open circle first. So x is greater than, so greater than is going to be all the values to the right. But because it's also equal to, I'm going to have to include negative 50, so I'm going to fill that in. So that's what we have. Okay, so for number 9, we have 4k, which means 4 times k, which is less than negative 12. So in this case, I'm going to do the inverse, which is to divide both sides by a 4. And again, I'm applying the multiplicative inverse. Why am I doing this? Because I'm wanting to create a 1. By creating a 1 here, I'm just going to be left with 1 times k, which is k. Now, before I write the symbol down, I'm going to ask myself once again, by any chance did I multiply both sides by a negative or divide both sides by a negative? The answer is no. I divided both sides by a positive 4, so this sign's going to stay the same. So it's going to be less than negative 3. So now that I have that, I'm going to go ahead and start my number line, starting with a 0. We're going to put negative 3 to the left of it. I'm always going to start with an open circle. K is less than negative 3, so all the numbers less than 3 is going to be pointing to the left. But because there's no equal to symbol as well, I'm going to go ahead and leave it open. So hopefully you got those ones right. Okay, so now that we've had some practice with some one-step inequalities, we're going to go ahead and move to two-step inequalities. Same idea, just keep in mind if you're ever multiplying or dividing both sides by a negative number, you are going to have to switch the inequality symbol. Okay, so for number 10, the first thing you want to do is undo addition or subtraction. So in this case, I'm going to get rid of this constant of positive 7 by subtracting 7 to both sides. That's going to leave me with negative 3x is less than or equal to a positive 12. Now I'm not done yet. I still need to get rid of this negative 3, which is to undo either multiplication or division. So I'm going to get rid of this coefficient by dividing both sides by negative 3. That's going to cross cancel, leaving me with x. Now, once again, before I actually write down the inequality symbol, I'm going to ask myself, did I by any chance multiply or divide by a negative number? The answer in this case is yes, and for those reasons, I'm going to have to switch the sign from less than equal to greater than or equal to, and 12 divided by negative 3 is a negative 4. So that would be my inequality, but we still need to graph it, so I'm starting with my number line. I'm going to go ahead and mark a 0, and I'm going to mark a negative 4. Always starting with an open circle. I'm going to go ahead and read this as x is greater than, so all the numbers greater than negative 4 will point to the right. Now, because it's also equal to, I'm going to go ahead and fill it in. And there is our graph. So real quick, what does this mean? X is greater than or equal to negative 4. That means any number greater than negative 4 will be a solution to this answer. So, for example, a negative 3 would work, a negative 2 would work, a negative 1.1 would work. Why? Because all of the values were on the right side of the number line. So please understand, with inequalities, there are multiple answers. They could be fractions, they could be decimals, and as long as it falls within the range of this line, it is a solution to the inequality. Unlike equations, there's only one answer, but with inequalities, you're going to find that there's infinitely many, with some restrictions, of course. Okay, so now let's try number 11. Why don't you go ahead and pause the video and try this one by yourself and see how well you do. Okay, so for number 11, we're going to first undo addition or subtraction. That's the easiest thing to do. So I'm going to get rid of this constant of minus 4 by adding 4 to both sides. So that's going to go away, creating a 0, because those are additive inverses, and that's exactly what I needed. Now I'm left with w over negative 5 is less than or equal to a negative 10. So now what we're going to do is isolate w by getting rid of this dividing by negative 5. And the way to do that is to multiply both sides by a negative 5. And so here, the negative 5s are going to cross cancel, leaving me with w. Now again, before I write down my inequality symbol, I'm going to ask myself, by any chance, did I multiply or divide both sides by a negative number? The answer is yes, you multiplied both sides by a negative 5, and for those reasons, I'm going to have to change this less than or equal to a greater than or equal to a positive 50. Now once I have that, I'm going to go ahead and graph it on my number line. I apologize that my number lines are always crooked. I'm trying. So here we're going to mark 50 in the correct spot. First, always starting with an open circle. I'm going to read this as w is greater than, so that's going to point all the way to the right. But it's also equal to, so I'm going to go ahead and fill that in. Now, real quick, let's talk about what this means. This means the number 50 and any number above 50, including decimals and fractions, will be a solution for w. Now, here you can visually see it. Do you think 0 is a solution? The answer is no. It doesn't fall within this particular range. So, remember that. Okay, so now let's try number 12 together. First, we're going to go ahead and undo addition or subtraction. So in this case, we're going to get rid of the constant of plus 4 by subtracting 4 to both sides, leaving me with n over 8 is greater than negative 23. Now to isolate the n, we need to get rid of this over 8, which means n divided by 8. The inverse of dividing by 8 is to multiply both sides by an 8. So the 8's are going to cross cancel, leaving me with n. And again, before I write down the inequality symbol, I'm going to ask myself, by any chance did I multiply or divide both sides by a negative number? The answer is, in this case, no. I multiply both sides by a positive 8. So for those reasons, my sign is not going to switch. So we're going to keep it as n is greater than. We're going to multiply that out. 23 times 8. 24. This is 16 plus 2 is 18. So we have negative 184. So let's go ahead and do a quick number line. We have 0, we have negative 184, always starting with an open circle first. N is greater than, so I'm going to go ahead and point to the right. It doesn't include the equal to symbol, so I'm not going to fill it in. So this is my final answer. So again, what does this mean? This means values for n, to make this a true statement, will include any number greater than negative 184, but it will not include the negative 184. It's any number greater than that. Okay, so now for number 13, I would like you to pause the video and try this one by yourself. Okay, so for number 13, I'm going to go ahead and quickly go over this. We're going to first undo the addition or subtraction by getting rid of this constant, leaving us with negative 3y is greater than or equal to 30. Now we're going to divide both sides by a negative 3. That's going to leave us with y. And since I did divide both sides by a negative number, the sign of the inequality is going to switch to less than or equal to a negative 10. So now we can start our number line. We're going to mark a negative 10. Since this is, first always start with an open circle, I'm sorry. Since this is less than, we're going to go ahead and point to the left. But because it's also equal to, I'm going to go ahead and fill in my circle. And there is our answer for number 13. Okay, go ahead and pause the video and try number 14 by yourself. So again, we're going to go ahead and undo addition or subtraction by getting rid of the constant, leaving me with negative 7w is less than 21. Now we're going to have to divide both sides by a negative 7, which, by the way, since we are dividing by a negative number, we're going to switch the sign to greater than negative 3. Now that I have that, I can do a quick sketch of my graph. Here's 0, here's negative 3. Always start with an open circle. Since x is greater than negative 3, we're going to go ahead and point to the right. And since it doesn't have the equal sign, I'm not going to fill in this circle. It will be open. Okay, so please keep in mind that this here is a lesson symbol. Some basic word phrases that's going to indicate a lesson symbol might be fewer than or is below. This is your greater than symbol, so some word phrases that might indicate this particular inequality might be more than or is above. Here we have less than or equal to, which is, you might hear phrases like at most or is no more than. And last but not least, this is your greater than or equal to symbol, which you might hear at least or no less than. So remember that. Okay, so for this particular problem, it does ask me to write an inequality for the word phrase. Next, state whether you will have to reverse the inequality symbol, and why or why not. So they're not asking me to solve, they're just asking me to write the inequality and to answer the question, will I have to reverse the inequality symbol? If so, why or why not? So here it says a number t is multiplied by 7 is at most 21. So t multiplied by 7 is going to look like this. 7 times t, which is 7t. At most means it could be 21 or less than 21. So I'm going to go ahead and write is less than or equal to 21. Now here, to solve, I technically would divide both sides by a 7. Now I only put that not to solve it, but to ask myself, by any chance did I multiply or divide both sides by a negative number? In this case, the answer is no. I only divided by a positive 7. So will I have to change the inequality symbol? The answer is no. And why? Because I wasn't multiplying or dividing by a negative number. That would be my reasoning. Okay, let's take a look at number 6. Same instructions. A number b divided by negative 4 is at least 7. Okay, so b divided by negative 4 is going to look like this. B divided by a negative 4 is at least 3. So at least 3 means it can be 3 or it could be greater than 3. So for those reasons, I'm going to go ahead and say that it's greater than or equal to 3. So this would be my inequality. But I'm not done. I need to answer the question, will I have to switch the sign of my inequality? Well, here if I wanted to solve, this is b divided by -4. The inverse would be to multiply both sides by -4. So if I multiply both sides by -4, will I be switching the inequality? The answer is yes, because if I'm ever multiplying or dividing both sides by a negative number, I will have to switch the sign. So will I have to switch the sign here? The answer is yes. Okay, because I will be multiplying both sides by a -4. Well, guess what? That actually concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye!